Hello students! In this video we need to talk about naming alkynes. So alkynes are hydrocarbons that possess at least one triple bond. So you can see that in that molecule called acetylene right there. So we'll discuss the characteristics and properties of alkynes in a different lecture, and I'm going to skip on down to the naming portion. So IUPAC nomenclature for molecules that have a carbon-carbon triple bond. Now, the nomenclature rules are going to work the same way that the nomenclature rules for our alkenes did. And alkenes, if you remember, are the molecules that have at least one what? One double bond. All right, so we changed the ending of our alkane from ane to ene for our molecules that have a double bond. So we're going to change the ending from ane or from ene to ine for molecules that have a triple bond. So you can see in this molecule right here that has 3 carbons, we have the parent part right there, prop, that indicates we have 3 carbons, and we have the ending YNE that indicates we've got a triple bond in there somewhere. Now, you might see propyne written as 1 propyne, but not very often. We usually just say propyne. And can you think of why you wouldn't need to have that 1 there? And we'll go ahead and we'll number the chain like that, 1, 2, 3. So we've got it between carbon 1 and 2, that triple bond there. Well, if we switched it around and we put the triple bond between the left-hand carbon and the middle carbon, what we would have is this right here. And then how would we number that? Well, we'd say we want the triple bond to have the lowest number possible. So we'll go ahead and say that it starts on carbon number 1, and the 1 would be on that side. And then we have 2 and 3. And that would also give us 1 propyne or just propyne, because either way, the triple bond is going to start on carbon number 1. So we don't really need the 1 there in the case of propyne. Now, when your chains get longer and longer, you definitely need to put the number in there, because you need to say, is your triple bond between carbons 1 and 2, or 2 and 3, or 3 and 4, etc., etc. Now, if we take a look at the next molecule to the right, you can see what I mean here. So we have 1, 2, 3, 4, 5, 6, 7. And if you have 7 carbons, your parent name is going to start with hept, but instead of heptane or heptene, we have heptyne. And that triple bond starts at carbon number 2, so you see it right there. Now, remember from the alkene lecture where we said that IUPAC has come up with a fancy new way to name these, because how we're doing it right here isn't precise enough. So it would really help if we went ahead and we named it hept2-ine, because that's so much more clear to everybody else out there if we put a number in the middle of the word. Ha 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 ha, right? What they said is if you put that 2 right next to the YNE, you for sure will know that we're talking about the triple bond being between carbons 2 and 3. So yeah, so if you see hept2-ine, that's not wrong, that's just a new way. All right, looking at the molecule to the right of hept2-ine, we've got 1 butene. So we have 1, 2, 3, 4. On all of these, we're numbering backwards. Interesting. All right, so this is telling us that we have a 4-carbon chain. It's got a triple bond somewhere. Where is that? Well, it starts with carbon number 1 and goes to carbon number 2. And remember that we only need to put the number where the triple bond or the double bond, if we're doing double bonds, begins. And we assume you know that our multiple bonds, which is both double bonds and triple bonds together, that they have to be between consecutive carbons, meaning between carbons 1 and 2, or 2 and 3, or 3 and 4. They cannot be between carbons 1 and 6, or 1 and 4, etc. All right, so what happens if we have 2 triple bonds? Well, we take a look at the molecule and we want to figure out our numbering. So we want to number to where we have a combination of numbers that are as low as possible. So for most of us, we can see right away that we're going to want a number left to right. So we've got 1, 2, 3, 4, 5, 6, 7. So we have a 1 and a 5 for our numbers. If we numbered the other way, we'd have 2 and 6. So 1 and 5 is definitely lower. And what I mean by 2 and 6 is that. So you'd have your triple bonds starting at carbon 2 and carbon 6, whereas if we number left to right, your triple bonds start at 1 and 5. So you want to have 1 and 5 rather than 2 and 6 because you want to have the lowest number possible. All right, so we would go ahead and put 1, 5, hepta, and remember that this A comes flying in from outer space because IUPAC said that it's easier to say if you squish an A in there. And the die is telling us there's 2, well, there's 2 of what, and then you've got the ion on the end there that's telling you there's 2 triple bonds. So the hept or hepta there is telling you you've got 7 carbons total. Now the new IUPAC way, we'd have hepta, 1, 5, diene. Interesting, huh? Numbers in the middle of the word. Right? Alrighty. And just in case you don't believe me, here's another example down here of where we have a number in the middle of the word. So looking at this molecule here, what we can see is that we chose to number backwards here because in numbering, the multiple bonds, double bonds, and triple bonds take precedence over our substituents when we're trying to get the lowest number possible. So you want the triple bond to start on carbon number 3. You wouldn't number this way so that your substituent would be on carbon number 3, okay? The multiple bonds take precedence in numbering to get the lower number, right? And so that gives us 6-methyl 3-octine, or 6-methyl oct 3-ine. Alrighty, let's do some more funky rules. And it looks like the switch to PDF strikes again, and we have a weird little symbol there. But that's okay, we'll roll with it. So if you have both a carbon-carbon double bond and a carbon-carbon triple bond, the bond with the lowest number gets precedence for numbering. All right, so let me go ahead and write that in. Okay, so if you have both a carbon double bond and a carbon triple bond, the bond with the lowest number will tell you which direction you're going to number the parent chain. It doesn't tell you who is going to get the ending. It tells you who's going to dictate the direction that you're going to number the chain. All right, so looking at this molecule down here, we can see that the triple bond is on carbon number 1 here, and that would mean that we're starting our double bond on carbon number 3 there. So we're going to number that one left to right, because if we numbered it right to left, we would have a 2, 4 there. Now, because the triple bond has the lower number, it does not mean that it gets the ending. And I know that's kind of how we think about it. Like, wow, that's the most important, so the ein should be on the end. But it's not that way. This means that it comes first in the name. And then the second number there is going to come second. So we've got a 5 carbon chain. So it should make sense. I'll just write it again, that we've got some kind of pent. All right, so what are we going to call this? Well, we call it 1-pentyne, and you'll notice that there's no E here. So IUPAC says that you rip the E off, and that's going to, I don't know, be better somehow. So we have A's flying into names and E's flying out. So we have 1-pentyne, 3 ene. And I've also seen pent 1 ein 3 ene like that, but I more often see this one right here. So we're gonna stick with that for this class. All right, so the molecule in the middle here, what you'll notice is that it's numbered right to left, so it's numbered backwards. And that's because that means that your double bond will start on carbon number 1. If we numbered it this way, we'd have your triple bond starting at number 2 and your double bond starting at 4. So we'd have a 2, 4 set of numbers. But if we number backwards, the pink will have 1 and 3. And 1 is smaller than 2, so we go with 1 and 3. So the double bond there is dictating the direction that we're numbering the chain. Okay, so it takes precedence for the direction of numbering. But whoever comes first in the number here is going to come first in the name. And that is not how we did it when we did alkanes. When we had branches, remember how the branch that came first in the alphabet came first in the name no matter what the numbers were. So ethyl came before methyl, even if it was like 5-ethyl, 3-methyl. We wanted to put 3 before 5, but no, it was E before M. So anyways, sorry about that. When you've got a double bond and a triple bond, whoever has a lower number is the one that's coming first. And so you can see that we've got a 5 carbon chain, so it's some kind of pent. Well, the double bond comes first, so that's a 1-pentyne, but notice how the E suddenly flies away and there's no E there. And then we put 3 ein, and that's because the triple bond has a higher number on it, so it goes on the end. And again, IUPAC says that we can do pent 1 ene 3 ine also. That's more specific, but I still more often see the 1 pentene 3 ine like that. Whew, okay. So what if you have a double bond and a triple bond and the numbering is the same either way you go? So what we'll see here is that with the pink numbers here, we've got a 1 and a 4. If we numbered backwards, we'd also have a 1 and a 4. So if you have the same numbers either way, so if you have ambiguity, the double bond gets precedence for the numbering direction. Okay, so since the double bond gets precedence for numbering direction, it gets the lower number. So that's why we are going left to right in this molecule here. So we have 1 pentene or pentane, 4 ine instead of having the triple bond first, okay? So, 50 million tiny little rules for nomenclature. Yes, that's how it is. Sorry about that, folks. All right, let's do some problems. So let's go ahead and name these. So if we look at this one right here, what we can see is that if we number backwards, we're going to have the triple bond starting at carbon number 3. If we number left to right, we will have the triple bond starting at carbon number 4. And remember, the multiple bonds take precedence over the substituents when we're trying to determine which direction to number. So let's go ahead and get rid of the blue pen there. Okay, so we've got a 7-membered chain. So our parent is going to be what? It's going to be a 3 hept what? Heptine, or a hept 3 ine. And our branches, we have a 2-methyl, a 3-methyl, and oops, not 3, I can't count, 5-methyl, and another 5-methyl. So a 2, 5, and 5, and all together these make 2, 5, 5 what? Trimethyl. So putting that all together, we have 2, 5, 5 trimethyl what? 3 heptine. Whew, long one. And again, folks, you could feel free to put trimethyl hept 3 ine if you so choose. Alrighty, let's do the next one. So are we going to number left to right or right to left? Okay, well, we've got a couple of choices here. Okay, so with the blue, the left to right, we have our double bond starting at 2 and a double bond starting at 4 and a triple bond starting at 6. So we've got, let me switch back to blue here. What we have is we've got a 2, 4, and a 6. And if we're going the other way, what we have is we have a 2, 4, and a 6. Ah, they're the same. Well, that's okay. UPEC has made a rule for that, and it is right here. And it says if you have that situation, then you're going to have the double bond have the lower number. So which are we going to choose? Blue or red? We're going to choose blue. So let's get rid of the red here and let's go ahead and name this. All right, well, we don't have any substituents to worry about, any branches, and we have an 8 carbon chain. So it's going to be oct something, right? Okay. Well, if we back up, we can see whoever has precedence in numbering, we're going to put that first in the name. So in this situation, we're going to put the ene first. So we've got 2 of those. So we can just go ahead and put a 2 comma what? 2 comma 4 hyphen oct what? Well, there's 2 double bonds. So a UPAC said you're going to throw an A in there in front of your Greek prefix. Remember that? Octadiene. And then it said if you have a double bond and a triple bond, you get rid of the E on the end here. So the A comes flying in from outer space and goes right there. And you get rid of your E, so we'll erase that. And then you have to identify where your triple bond is. So you would say 6 what? 6 ine. So 2, 4 octadiene or octadiene, 6 ine. Now, could you number this a different way? Yes, you could. You could say octa, 2, 4, diene, no E, and then 6 ine. Okay? This is the new IUPAC version. It's supposed to be just, more precise. So there we go. Alrighty, going down to the cyclic structure. Yay! Okay, so who do we want to have the lowest number possible? That branch right there or that triple bond? Well, if you said triple bond, you're correct. Now remember that your double bonds and triple bonds together, called multiple bonds, need to be between consecutive carbons. And when you have a cyclic structure, you can go ahead and say, okay, my multiple bond is going to start on carbon number 1, and that means that it's going to be between carbons 1 and 2. Now you could have done 1, 2 like this, but which way are we going to go? Well, then you want your branch to have the lowest number possible. So if you were to number counterclockwise, you can see that this branch right there would be on carbon number 7 instead of, if you number in the blue, which is clockwise, your branch would be on carbon number 6. So we're going to choose to number clockwise, which is the blue. So let me go ahead and erase all of the, oops, wow, that didn't work there, so I'll just do this. There we go. All right, so what is our parent here? So just thinking out loud, and I'll erase this right here so we have a little more room. Okay, so our parent is going to be what? Well, it's a cyclic structure, so we want to write cyclo right away so we don't forget it, because that's a common student mistake. So we've got cyclo, and then if we have 10 carbons, do you remember what that parent is called? Well, if it was an alkane, it would be decane. If it's alkene, it would be what? Decene, and then this is going to be what? Decyne. Yep. So we have cyclodecyne. And where does that triple bond start? It starts at number 1, so you could put the 1 right there. Now, the thing about a cyclic structure is if you only have one multiple bond, you're going to locate it at carbon 1. So if you only have one double bond or triple bond, you don't need the 1 there. So let's go ahead and erase that. So we've got cyclodecyne. And what do we need to stick in the front? Well, we need to put that branch there. And that branch is what? Well, if you need to draw the carbons in for your own good, go right ahead. And this one right here would be a CH. You can see that there's 3 carbons there, and a 3-carbon chain is some kind of propane. But we're connecting to the center carbon, so that's a special kind of propane. Looks like a little snake tongue there. And that's a what? That is an isopropane. And when we have it as a branch, that's an isopropyl, and it's located on carbon 6 of the cyclic structure, and we stick that together, and we have 6 isopropyl cyclodecyne. Whew! You could also do isopropyl cyclodec-1-ine if you'd like, but you don't need to do it that way. Okie dokie, let's do some drawing because drawing's always fun. All right. Number 2 here says draw 5-ethyl 2,5-dimethyl heptine. All right, hept means we have how many carbons? 7. So just go ahead and do a line bond structure because again, you don't have to worry about how many hydrogens are everywhere. So we do 1 when our pen hits the paper, okay? So there's our first carbon right there. 1, 2, 3. Darn it, don't do that. 1, 2, 3. Stop it. 1, 2, 3, 4. Okay, this is just gonna drive me crazy tonight. 1, 2, 3, 4, 5, 6. Stop it. 7. So we got 1, 2, 3, 4, 5, 6, 7. Now the 3 right here is saying that we have a triple bond starting on which carbon? On carbon 3. So it's between carbon 3 and 4. So we're going to want to go ahead and make that a triple bond like that. Okay, so we've taken care of that. And now we have a methyl on carbon number 2 and carbon number 5. So I'm going to go ahead and erase that like that. Okay, so we have a methyl on carbon 2. And we have a methyl on carbon number 5. And I'm going to draw it out this way because I want to leave space because there's another substituent or another branch on carbon 5, which is ethyl. So we took care of the 2,5-dimethyl. And then the ethyl has how many carbons? 2. So we go 1, 2. Stop it. Darn it, why did you do that? Well, I guess you could draw it that way, but that doesn't look very good. Okay, so 1, 2. Now, could you have put this methyl right here where the ethyl is and put the ethyl where the methyl is? Absolutely, you could draw it like that. As long as you've got a methyl and an ethyl on carbon 5 there. So let's go ahead and clean this up a little bit and erase these just so nobody grading it thinks you accidentally drew in. Oops, got rid of my methyl there. Don't want to do that. something that you didn't mean to. Now, this structure here is okay for an introductory class, but what you should keep in mind is that the triple bond, it's actually going to force the geometry in that zone to a linear geometry where you have a 180-degree bond angle. So how you'll see it drawn is like this, friends. And it's easiest if you start with the triple bond, and what you do is you draw a couple of parallel lines far enough apart that you can put a longer line in between. And what's weird about this type of drawing is it's easy to miss a couple of carbons. So carbon 3 is here and carbon 4 is here. Carbon 2 is right here and carbon 5 is right here. And then we can draw the rest of the molecule. So we can go down like that and have carbon 1, and then on carbon 2 there's a methyl group. So there's a methyl group there, and then 5 is there, and then we have 6 and 7. So we've got 6 and 7 here, and off of 5 you're going to want to do the methyl and the ethyl. So if we were to draw in all of the carbons, where they would be is here. So with triple bonds, because they force this angle right here to be 180 degrees, it's easy to miss those two carbons right there. So just be really careful of that when you see that on a piece of paper, to not miss those when you're doing some naming. So let me go ahead and take all of that out so you can take a look at the structure again. Okay, so that's what it would look like because more often, because that's got a more correct geometry on it. Alrighty, that is the end of naming alkynes. I will see you in the next video. Bye-bye.